All right, Mr. Eden, you feeling good about this?
I'm feeling great about this. How you feeling, Charlie?
I'm feeling good for a Friday.
All right, all right. Why are you feeling good? What you got going on this weekend?
Well, I'm trying to get fired up still. I've only one cup of coffee into it. But hey, it's Friday, guys. It's not Monday. So we got some traveling to do next week, so we're filming a little early. So, it's Friday morning and we're fired up.
Yeah, Friday fun day.
That's right. We're barbecuing today, right?
Yeah,
At
I think they're
lunchtime.
going to see some clips of that later, no?
You know what? We will go hit up our little barbecue session because I know we call this fan addicts, right?
Right.
I'm a barbecue addict, I gotta say.
That's not a bad thing to be an addict.
Yeah.
Especially when, dude, you were telling me some of the stuff you cook up.
I like, hey, CT Fan Man's Instagram, right? So if you guys like trucks and barbecue, that's usually what I got going on my Instagram. So
Fair enough. I mean, hey, we could talk about barbecue for hours,
Hey,
but
yeah.
let's dive into heat sinks today.
No, you're jumping ahead.
Oh, my bad.
Hey, how are we supposed to start?
My bad. You're right. You kick it off.
We're supposed to do, what are you doing? What'd you do this weekend? Well, since it's Friday, what are you gonna do? So I'm starting with you. What are you going to do this weekend?
What am I going to do this weekend? I'm going to make a whole bunch of cookies. I'm going to go run them over. We're doing it's called like the Global Village. So we're doing a booth to represent our country, and I'm going to make some. And
Nice.
Yeah.
Sounds like a good time.
From there, I've got a few open houses and just going to keep the hustle hustling.
That's cool. Yeah, I don't know what I'm doing this weekend. Haven't really given it thought yet. So, my wife's a Led Zeppelin fan, and one of her friends was telling her about this cover band. It's called Led Zeppelin, and they're playing out at one of the Indian casinos this weekend. So I might end up out there.
Cool. Enjoy.
We'll see.
Let me know if they're worth it, because Led Zeppelin, that's a pretty bold name.
Yeah, they're supposed to be a really good cover band, but, we'll see.
Cool.
So, I guess that's that, right?
Yeah.
I guess maybe when we come back next week, we'll have maybe something exciting will go down.
Yes, sir.
Right now, we're just rolling into an easy week. But one thing I will comment on next week, what I'm doing is we are going to be attending Open Compute seminar up in San Jose. It is a conference for AI computing, data centers, and all that kind of good stuff. So I'll be up there with Tosh, our Eastern regional guy, and we've got Graham Chen, our CEO from Taiwan's coming in, and Irina, who's heading up one of our business units that's going to be focusing on data center and what we call our telecom high-performance computing product line that's coming out next year. So if any of you guys happen to see this, look us up next week. We'll be roaming around the show and in and out of various talks.
I love the innovation.
Sweet.
All right.
All right. So what do we got on board this week? What are we talking about?
We got heat sinks.
Nice.
You wanna tell us what exactly is a heat sink?
So, I won't get into what we did, but a heat sink in general, right, is typically something that you are going to mount on devices, ICs, IBGTs, all these different board level components that get hot, right? So most engineers are always trying to dissipate the heat without an active solution. And you say, well, wait a second, we talk about active solution. That means if you have a fan on it, right? So think of it as you have active air blowing on it versus passive, right, would be just a heat sink with nothing else going on. You're relying on natural convection. So a heat sink by design is you are putting a piece of metal on a device to draw the heat off it and help it run at a temperature that works for its operating parameters.
Interesting. So I understand there's multiple types of heat sinks. Could you dive into a little bit about what those different types are?
For sure. And there's a lot of them these days, right? So, we've got the basic one would be an extrusion, right? So extrusions are typically made out of 5,000 or 6,000 series aluminum. We got a little picture right here because I think pictures are worth 1,000 words. So we'll kind of, instead of me having a prototype or a sample here in front of you, we'll put some pictures up that have a better definition so you can see exactly what they are. But an extrusion is a two-dimensional profile that we can extrude, cut, machine, put drill and tap, surfacing, anodizing, all that kind of good stuff on it. So extrusions are the most common. So then after that, you've got castings, right? So castings are what I would call a three-dimensional part, right? So you actually make a mold for it, and then you can have, it's not just one direction of fins. You can have all kinds of different things going. So we've got a picture right here of a really cool casting that we've done with the fan on it, and this, by the way, was something that we did as a complete subassembly for our customer, that actually really helped them out in their manufacturing process. So extrusions, castings. After that, we've got like skiving, right? We've got a picture of a skive part here. Skive's interested because they're very high performance, right? I won't get into the technology of it right now. That's stuff that we'll look at in future episodes where we actually do the deeper dive into, okay, how do we manufacture this? Why is it so good at performing, right? But those are really interesting because you can actually do them out of copper or aluminum.
Interesting.
Right. So we've got skiving, and then we get into zipper fin, right? That's a whole nother, that's for really high performance computing as well. You're going to see those in like server applications or other areas where you just can't get the fin density that you want. And then supplemental parts that can go on various forms of all these technologies I just said is like vapor chambers and copper plates and heat pipes. And so again, that's why we're a thermal solution provider, right? We like to integrate what the best solution is for you with the fan or not, right? And whether, you need all these fancy options. So that's part of engaging and working on, what the design needs and coming up with the best performing part for the best cost structure.
I love that. And then you mentioned like design needs. So could you dive into a little bit about what industries use heat sinks more specifically?
Sure. Well, the thing is it's across all boards, right? So you say, okay, well, what industry is it? And I'd almost go, well, if you've got a PCBA, which is a circuit board in simple terms, right? That when you open up something, you see a board in there with all these little things all over it, right? Those are all components, transistors, diodes, MOSFETs, like all the things that make your electronics work. Well, when you run electricity through things, that makes them build up some heat, right? And so the verticals that we call on, right, because we kind of establish where our key verticals are based on our fans and the things that we do well in that market, because we want to be selling thermal solutions, right? And so getting into it, telecom, right? If we're talking about 1U and 2U servers, those are going to primarily have zipper fin and skived heat sinks in them, right? You can get into super high power stuff and they may have bonded fins and these larger heat sinks, or even going into cold plates, right? And I forgot to bring up cold plates because we do cold plates as well. And so I don't forget, side note, cold plate, water cooling, chiller, we got something super amazing. Actually, when we go walk out, maybe do a little drive-by on the barbecue here after we're done, we'll take a little peek in the lab because we got something super special coming up. I'm not going to say next, but 2 weeks, I think we'll have that episode out when we have the unboxing of the super cooler.
Super episode with
It
the super
is.
cooler.
This will be one of our first demos on a working sample that we have coming in on a whole system of stuff that I won't let out of the bag yet. But anyway, so back to that, we do in automotive, automotive uses a lot of castings, right? Because you have very unique shapes and the things that they do, whether you're talking about amplifiers or headlight assemblies or whatnot. So in a casting, you can make these unique shapes. You can still bond fans to them, and have all that going on. Again, the electronics world in general, you have a lot of extrusions, for that type of stuff. So it's so much stuff. And that's like, that's why we're just hitting on a high level of what the technologies are. And then as we roll out all these episodes over this, end of the year and going into next year, these are the specific things that we'll dive into on a kind of a case study or case-by-case basis where we can do deeper dives.
Got it. Awesome. And then I wanted to ask you, if I'm an engineer choosing between the different types of heat sinks, what's important? What really matters?
It always comes down to identifying what you need, right? Sometimes Like, we always talk, I like cars and stuff like that, right? And I'm a truck guy. I've always loved towing trailers. So I like to make analogies there because it works out for people, right? And so it's kind of like sometimes you want to have the lowest cost solution, right? You go in, that's the whole point is, we want to build the great cost structure. And you may want a certain technology, but it's like if you're in a very high performance situation, sometimes like you may want an extrusion. Like I'll give you an example. I know we're kind of rolling into it of like, hey, let's have an example of something like that. Well, I was working on an automotive application years ago, and these are very high volume things. OEMs are very smart about what they do, and they usually have either a design preset, right? So when they come to you, they know how much airflow they want from the fan. They know the size heat sink they want, right? So they come in and it's like, okay, we want this thermal module. It's a heat sink, a heat pipe, and a fan, and all this stuff. Really elaborate setup, right? So we engage with them. We're doing a simulation on what they've offered us, and we go, it's impossible, right? You're not going to achieve your temperatures that you want for the components you're trying to cool with an extrusion. It just isn't possible. And they're like, well, what do you mean? And you're like, well, the physics of it doesn't work, right? You can't get that amount of heat dissipation out of that. And they're like, well, what do you guys recommend? So we do some work, we're doing the engineering on it, and we're like, well, if you go to a zipper fin heatsink, and you saw the picture earlier of the zipper fin, right? So it's really thin fins.
Let's put it back up just so they can see again.
So a zipper fin, and there's different terms out there, but it's kind of common. But being able to take that technology with how it's set up and integrated with the fan, we were able to meet the needs. And they came back and said, oh man, you know what? That's interesting, but we've never used that technology before and we're not too sure about it. I'm like, okay. And so what do you mean not sure about it? Well, quality and reliability and will it hold up in a vehicle and all those things. So, because it is a soldered part and it's assembled and, it's not just a one-piece extrusion or casting. Well, long story short, they said, okay, well, we're going to go do our own thing, right, and figure it out. They came back 4 or 5 months later, and they're like, okay, we're ready to go with the zipper fin heatsink. So, sometimes it's like, our goal is to help people understand what the options are and be able to accomplish a goal within the package size that they have to work with. So when you ask how or what do you do, it's so many things. You just have to get in to start doing the design work. And a lot of those solutions do come with the simulation or getting into the final, total design because the real estate that you have available in there, ambient temperatures, all these factors come in. So,
and we'll get into more of the simulation on later episodes, explaining
right.
all that and whatnot. You've skipped ahead a few questions, but
I know I just ran them all together because I got it going. So
you're good. You touched in the beginning of the episode on passive and active cooling. Could you just take a deeper dive into that a little bit?
Yeah. So the whole way that heat sinks work is, and this is true for heat dissipation, is you want the maximum amount of surface area, right? So when you're drawing heat off something hot, so the fins, we can put a picture up, but when you have a heat sink, the whole reason they have all these fins is because that's surface area, right? You want square, if you're talking square millimeters, square centimeters, whatever. So the more surface area, the more heat you can dissipate. Well, so you get to a point of, okay, natural convection will get you to a certain point. Well, if you put a fan on it, right, and you blow air across it, it accelerates that. So it speeds up the process of the heat dissipation. So active is adding a fan, passive is not. So, it just depends on what the goals are for your application in the company. Some people would prefer to put, you say this size heatsink doesn't work, they're like, well, we'd rather make it bigger. Like, how big does it have to be? Because we don't want a fan, right? Some people don't want to hear it. Some devices, they don't have mechanical things in there that are operating because mechanical parts are where you have to weigh reliability concerns, right? Mm-hmm. So, yeah, I mean, there's many layers to it, right? And so passive and active, a mini goal is always to be passive.
Got it.
I mean, it usually always is, but I say that's the story of my life, right? I've always been a fan guy, so I'm here when you need it.
Fair enough. So you did touch briefly that we are going to have an episode doing an unboxing on what's next, but Can you just explain to us kind of where heatsink technology is going and how YS Tech is innovating for the future?
Yeah, so for us and what we're investing in now is a lot of water cooling, chillers, and fan and cooler applications for data centers. So everybody talks data center, and it is kind of the way of the world going forward. And so whether it's AI processing or data storage and all that, that is what we're looking at. So, where we're headed is going to be part of that unboxing.
Awesome. I think everyone's kind of on the edge of their seats looking forward to it.
We'll hope so.
Cool. Well, I mean, hey, that wraps it up for today. You got anything you want to tell our lovely fans out there?
Yeah, no, it's all good. And I think we'll take a cut here, but we'll pick this up in a second, and maybe we'll do a quick hot lap through the building and out, and show you what we got on the grill, and a little sneak peek at the box.
All right, sounds good. Cool.
All right, guys. Well, happy Friday, and keep it cool.
Keep it cool.
All right.